This will be an example that looks at solving a quadratic by completing the square, and then I'm also going to solve the same quadratic with the quadratic formula, which will result in the same answer, but it's just two different processes. So for this one, to complete the square, we need to get all of the variables on the same, or all of the terms on the same side. So I'm going to add over the 6s and subtract the 1, set it equal to 0. First step in completing the square is to have the s squared terms coefficient 1. So I'm going to factor out the 2, but I'm going to factor it out from every single term. So if I factor a 2 out from 6, I'm left with positive 3s, and then I'll have negative 1/2. Okay. After I do that, I'm going to group the first two together. So I get s squared plus 3s, leave the minus 1/2 separately. Then come up with that number that gets added and subtracted that you get from doing half of the middle term and then squaring it, so you get 9/4. So we'll add 9/4 inside and subtract 9/4 outside. And then we'll have 2 times the factored quantity of s plus the 3/2 squared. And then the negative 1/2 minus 9/4 should become negative 11/4. Right? We make that 4 and that 2. Yeah, negative 11/4. And then you can distribute that 2 through to those quantities. And you get 2 times s plus 3/2 squared minus, if you do 2 times 11/4, you end up with 11/2. And now we're at a position where we can solve. And the idea here is to get that quantity that's squared by itself with everything else on the other side of the equation, and then we can plus or minus square root to get our two answers. So if we do that, we'll add the 11/2 and get 2 times s plus 3/2 squared equals positive 11/2. We'll get rid of this 2, so I'm going to multiply by 1/2. And then s plus 3/2 squared equals 11/4. Then I'm going to square root both sides, plus or minus. S plus 3/2 equals plus or minus the square root of 11, and it's going to be over 2, because if you square root 11/4 and then break those two apart, you can actually square root 4, but it'll leave a square root of 11 in the numerator. So the square root of plus or minus the square root of 11/2, and then I'll subtract the 3/2 over, and I get that x is negative 3/2 plus or minus the square root of 11/2, or you can put them over the same denominator of negative 3 plus or minus the square root of 11/2. But when you answer these online, you'll have to give the negative answer, or the smallest answer, and then the largest answer. So you do need to get two different forms, but it would be a good idea to get decimal answers to determine which one is the smallest and which one is the largest. So order for Wiley answers, because you're supposed to answer in increasing order. So just be mindful of the fact of which one is smallest and which one is largest. The other way that you can look at this is using the quadratic formula. So for ax squared plus bx plus c, that's your standard form, you can pull the coefficients a, b, and c off, plug them in the quadratic formula, which is this quantity. And if I move all of these terms in my equation, same equation from before, to one side, I get 2s squared plus 6s minus 1 equals 0. The a term is 2, the b term is 6, and the c term is negative 1. So plugging those into the quadratic formula, we get negative 6 plus or minus 6 squared minus 4 times 2 times negative 1 all over 2 times 2. Cleaning that up, we get negative 6 plus or minus. So under the radical, 6 squared minus, or it would be plus 8, would be 36 plus 8, which would be 44. So we can square root 44 and throw it over 4. And then you'll have to address whether or not the square root of 44 is simplified, which in this case it is not. You can't do anything over here with this 6 and 4 yet, even though 6 and 4 are both divisible by 2. You're still missing something to divide in front of that radical, so you can't do any of that division simplifying yet. But we can simplify the square root of 44. Square root of 44 will factor and break apart into square root of 4 times 11. And you can do the square root of 4 separately from the square root of 11, and that becomes 2 times the square root of 11. So the answer further simplifies into negative 6 plus or minus 2 times the square root of 11 over 4. And then back to those areas where you have to look where you can simplify them. So if you look at this negative 6, this 2, and this 4, can't do anything with the square root of 11. Every single one of those will divide by 2. Or you can divide out of 2, however you want to think about it. So this becomes 3, this becomes 1, this becomes 2. And what you're left with is a negative 3 plus or minus the square root of 11. Don't write the 1 in front of it. Over 2, which does give you 2 answers. And again, if you want to split that apart, it's negative 3 over 2 plus or minus the square root 11 over 2, which should be negative 3 over 2 plus or minus square root of 11 over 2, the same thing we got from completing the square. And you're welcome to graph it and see the zeros where it crosses the x-axis. But the method that you will have to show is how to use the quadratic formula, or perhaps how to solve completing the square. So you need to be able to solve using either one of those methods, knowing you can use either one of them to get the answer or graph it to get the answer, but you have to know how to show the solving of that method by hand. And that is completing the square method and then the quadratic formula method.